Alright, last rational graphing problem from number 3. Again, let's factor. So numerator, x squared minus 9 is a difference of squares. So x minus 3, x plus 3. Denominator, I have an x minus 3 factor to start. Look, that's going to cross off. That's a whole. But I have x squared minus x minus 6. How does that factor? Two numbers that multiply to negative 6 and add to negative 1. So, what is that? Well, let's give ourselves two parentheses, like that, x and x. Multiply to negative 6 and add to negative 1 has to be 3 and a 2, right? So 3 and a 2, but what's going to happen here? This is kind of weird. So x minus 3, x plus 2. Notice I have another factor of x minus 3. That's kind of goofy, but it's also kind of cool. So we'll see how that happens in a moment. What happens with that, I should say. So x plus 4 right there. So factored. Let's rewrite it with that whole removed. With the whole removed, I get x plus 3 in the top over x minus 3 in the bottom, x plus 2, and then x plus 4. So let's start listing things, and something weird is going to happen with this, but it's okay. We'll deal with it. So, x-intercepts. X plus 3 gives me an x-intercept at negative 3. So negative 3, comma, 0. Horizontal asymptote, degree in the denominator is much bigger than the degree in the numerator, so y equals 0. Y-intercept, plug in 0 for x, which means in the numerator, I have 3. In the denominator, I have negative 3 times 2 times 4. So those 3's cancel, and I'm left with 1 over negative 2 times 4. So I'm left with negative 1/8 as that y-intercept. So 0, comma, negative 1/8 right there. Okay, holes and vertical asymptotes. This is where it gets weird. I know I removed an x minus 3 over x minus 3, but I'm actually going to say that we don't have any holes. The reason I'm going to say we don't have any holes is because I had 2 powers of x minus 3 in the bottom. So although I took one away, I still have an x minus 3 in the bottom, which actually means that I sort of, kind of, totally have a vertical asymptote at x equals 3. So that's kind of weird. Right? It's like I had a hole there, I took it out, but I still have an asymptote there. And that kind of overpowers the hole in a way. So let's call it x equals 3. Let's look at the x plus 2. That's going to give me an x equals negative 2. Let's get the x plus 4. That's going to give me an x equals negative 4. So I have all the stuff, and now I can sketch this puppy in. So axes. Let's go 1, 2, 3. Put in my x-intercept. Let's go 1, 2, 3, put in my vertical asymptote. X plus 2 is going to give me a negative 2 vertical asymptote. X plus 4 is going to give me a negative 4 vertical asymptote. We said the horizontal asymptote was at 0, so like that. And we figured out that the y-intercept was at negative 1/8. So it's a negative number right in that area. So, let's sketch this information. Where do we start? Let's start with that y-intercept. That's negative. And if I look from that y-intercept to the left, to that first asymptote, I have no x-intercepts there. So, gotta go down. Okay? What about to the right? To the right, same deal. No x-intercepts between that y-intercept and the vertical asymptote. So I also have to curve down. So it's going to look like that. Alright, now what about multiplicities? Multiplicities of all of the vertical asymptotes are 1, which means they will all be on the opposite sides. So since that's down to the right, I'm going to be up like that. Boom. Boom. Same thing over here. Since that's down over there, I have to be up over here. I have to hit that x-intercept, and I have to cross through it because that x-intercept has a multiplicity of 1. Yes, I just crossed in a horizontal asymptote, which is 100% totally allowed because all a horizontal asymptote is end behavior. It doesn't tell you what happens in the middle of your graph. It tells you what happens at its extremities, far to the left and far to the right. So I crossed through, which means, since that's down to the left, this thing has to be up. So we get that right there, and I think we're good.